Hello, everyone. Welcome to this week's bounty episode of the podcast. I was going to say binary, but I got my days confused. I'm Spectre. With me is Z. Quick mention before we get started: you may have seen the spot the vuln solution or challenge on the start screen. The solution to that will be covered in tomorrow's binary episode. And if you missed that challenge and want to take a look, it'll be in our Discord in the spot the vuln channel, as always. But yeah, with that said, we'll get into some topics here. So our first topic is from Rasmus Sten at F-Secure Labs and is on macOS Gatekeeper, which we've seen some issues in before. We've talked about them. Um, Gatekeeper being the mechanism that macOS uses to check untrusted files for malware and whatnot and validate code signing. This post is about a bypass that involves one main issue, but possibly a second issue. I'm not sure on that. Maybe that's something we can maybe have a discussion about later, but the primary issue here is the when you have path names that are too long inside of something like an archive file, um, the gatekeeper attributes attached to those files or directories inside of it will be removed when extracted, which macOS relies on to know whether or not it needs to run that file through gatekeeper.
So I
Uh,
I
so
don't think it's the case that they're removed. It's that they're not applied. So Gatekeeper relies on applications to actually apply that calm Apple quarantine attribute onto all of the files. So like your browser will automatically apply that to everything it downloads. Similarly, Archive Utility, I believe, will apply that when it's extracting files from a file that has quarantine or that is supposed to be quarantined itself. And what seems to happen here is it fails to apply it rather than removes it.
yeah, I see. So yeah, they kind of cover here that it fails to inherit it. Okay,
Yeah,
so
so like so what seems to be happening, and I will also mention there is a really deep dive as a part two to this post that goes far deeper than I think this vulnerability. Maybe I shouldn't say than it warrants, 'cause are some interesting things there, but like it's diving into reverse engineering archive utility to figure out exactly how this bug happened, just far deeper than like what you need to understand the vulnerability. So there is kind of a second post on that. That said, core issue just seems to be having that really long path, like longer than path max. So this says Mac OS doesn't want a path this long. Uh, Having a path, then when it tries to apply the quarantine attribute to all the files, it seems like it's doing the extraction and then applying it. Because what ends up happening is when that error happens, it just kind of has this early return case. It stops applying the quarantine attribute or never ends up applying them on all the rest of the files. So even for files that do have shorter paths, they don't get the quarantine attribute either. And that is kind of important when it comes to the exploitation aspect, because having a really long file path, uh, not only are you having this quarantine issue, but with that path, like Finder might have issues actually opening it, or it might not even be executable because of that, just because it has a very long name, which was kind of one of the problems they had to solve with exploiting this. They ended up doing it using some symlinks to uh, basically make their directory look like a single app, did some creative work there. But ultimately, it just comes down to, I think, the one issue of not handling the path max error, where you have a path longer than the maximum path length. What was the second issue, though, that you were thinking of, Spectre?
So it actually comes up with the symbolic link technique you mentioned. We're getting around the issue of having a long path, but also keeping it short enough to work in Finder. Because they point out that while the symbolic link itself will keep the gatekeeper attribute, that attribute doesn't get respected and it just follows to the main file anyway, which doesn't have that attribute attached to it. So I don't know. That seems like kind of an issue to me. It seems like you would want to read and respect the attribute of the symbolic link file itself, but I don't know. I guess that I could see it going the other way too.
I
So
could
that's why I
understand the
wasn't sure if
decision.
I would want to call it
Yeah, no,
an
I
issue.
get where you're coming from. I didn't really take it as a vulnerability when I was first reading this. Pointing it out, like, I could understand the reasoning behind maybe considering that because it's not respecting it through the symlink, but it is respecting it through the actual binary. And the concern seems to be more the case of having binaries run without having them actually execute or going through the normal code signing check and all of that that quarantine enforces. So by worrying only about the target binary, kind of makes sense there because you're not executing the symlink itself. You're just kind
Yeah,
of following it along. So, oh no, I'd want to see, I guess, a proper attack abusing that before I really came down and called it a vulnerability. I mean, I'm
it's
not saying it can't. I'm just not really thinking of anything.
it's a little funny because it's kind of specific to this issue. Like this issue, they couldn't have exploited it the way they did if the symbolic link attribute was read. But at the same time, there's probably not many situations where the symbolic link needs, or the attributes on the symbolic link would need to be read, because it kind of, there has to be a pre-existing issue for you to really take advantage of that, like one that exists in this situation. So I don't know. It's a little bit interesting, but
Yeah, 'cause
yeah,
the
they
only
don't call it an issue in the F-Secure post. So that was just, kind of something I wanted to bring up a little bit and have a bit of a discussion about when we covered it.
Yeah, the only way I could really kind of imagine that coming into play normally would be in the case of, you know, I guess an archive, sticking with that. An archive extracts a symlink, but it goes to an existing binary. Um, then you would have a case where that symlink would have it, but the binary they already know is safe. So that's kind of where I'm coming down on. I don't actually see the attack surface for it.
Yeah, which is fair, I think. So yeah, I mean, relatively straightforward issue. It is funny seeing, like, I think we've covered a few gatekeeper bypasses in the last year or so. It
Covered a
seems there's been a
few,
lot of
yeah.
research going into that, which makes sense because if you're, malware developers and stuff have an interest in getting around gatekeepers, so it's good that there's people looking at it. But
Yeah, I mean, I like seeing also these path issues. 'Cause it's a subtle, or I mean, it's somewhat subtle when it happens. Well, not always actually. I guess I can't say it's always subtle, but these issues around having a really long path, one of those issues that I would often forget to test until I was actually looking at like my test plans, like, oh yeah, I've got to test this too, and like take a look and make sure it handles that because a lot of developers just don't think about what happens if my path or file name or something is too long. And I mean this is outside the overflow concept, just normal applications, it's not something you're always thinking of or even necessarily aware of. So I've seen some interesting bugs in that. So this is just kind of another manifestation of that. But they are usually very application specific.
and it's kind of funny you bring that up because this was actually discovered by accident. The F-Secure Labs post has like a little discovery section. They say like they were testing how long path names appear in their own UI, and then ended up inadvertently discovering this issue in Gatekeeper. So it's funny you bringing that up because that's exactly like what they were testing for, but they weren't trying to find it in Gatekeeper. They were trying to find it in their own application. So um, just shows how important testing can be and with something like that. So
Yeah.
all right, so next up we have a topic about malicious Android apps and how those can steal first-party access tokens to Facebook, Messenger, Instagram, and other Facebook-owned applications. This is from Yusuf Samuda, who I believe we've covered before, covering Facebook issues. Um, the way that a lot of these attacks work is by registering deep links that hijack ones that Facebook use, like the FB app authorize and FB Connect success, and bypassing some of the existing defenses that Facebook has implemented against those, since some of the more trivial attacks have already been reported.
Yeah, I mean, in
So
this case, like, Facebook is aware of this idea. They know that you can go and, register these things. So they do have some defenses, or at least they should, as you'll see later. But yeah, it's actually I haven't seen this one in particular before. I mean, they're saying it's common. I absolutely believe that if you're doing more tests against, I haven't done a lot of tests actually, like engagements where OAuth was being used, quite like how Facebook ends up using it. So like Facebook has a uniquely large attack surface just because you have a lot of applications using their OAuth versus just integrating with someone else's OAuth.
Yeah, they kind of have their own ecosystem with like how they synchronize the auth flow between like Instagram and all the products that Facebook owns. So I think that's like the major key as to why the attack surface is so large and why the flow is so complicated to follow.
Yeah. But yeah, I mean, this attack, just the idea of registering another scheme totally makes sense as an attack. I don't think I've really looked for that before, I'll admit, but uh yeah, still like an interesting way to go about, especially if you're not looking at Facebook. I could imagine other applications or other OAuth providers potentially being vulnerable to something like this, using the deep links. Anyway, might as well dive into them.
Yeah, so the post starts off with talking about what some of the defenses against those deep link hijacks are. They cover like four of them, I believe. Let me just scroll down to them here. So yeah, like they do some whitelisting where only like the FB and FB work work for things like the Facebook and workplace applications, and other URI schemes like FB Connect won't work. So just trying to sandbox off uh the schemes to what apps actually need them and what apps don't. Just trying to do some attack surface mitigation, and that's applied when using Facebook or workplace web views. Another thing they try to do is check the user agent to see if it's mobile and ask for confirmation if it is. They also do some server-side checks in the OAuth endpoint for third-party applications to use to try to ensure that the app gives an app ID that it actually owns, which we've covered an issue in the past that kind of touches on that actually with getting the server confused between app IDs. And then finally, they do some key checks against the calling package key and the Android key, which is supposed to be like a per app key. And they check those if certain headers are present in the requests, like X requested with Katana, for example, which I believe is like their proxy
Yeah,
application.
so because with the native application, if somebody were to just like try and make these requests manually, they wouldn't have all the Facebook cookies. So they need to kind of go through the Facebook application. That's what Katana and the um proxy auth activity that it exposes. That's what it's basically offering. You can go through the Facebook app, so you get the Facebook login already there.
Yeah.
Um, so that's where it then adds these headers to indicate it's coming, and adds the parameters, the Android key, and the package key. Um, those are coming from Katana, so a little bit more trusted because the user's already logged in. It's not just trusting whatever app ID you can provide, unless you can intercept the request. But if you're in that position, you can already intercept the tokens, so it doesn't really matter.
hmm So yeah, they do those checks against the keys, and if the keys don't match, it'll reject the request. So the first bug or bypass is that the workplace application failed to implement um, the OAuth measure for checking against third-party apps claiming to be first-party apps. So they could just register an authorized scheme under a first-party app ID to get a token. Kind of straightforward. The second bug, the proxy process for interacting with Facebook's auth doesn't generate a key for some applications like Workplace. Their guess there is just that there's some applications that are unsigned or don't use the Facebook Android SDK. Maybe they're using some internal SDK or something. And then on top of that, the server side behaves a little bit differently when comparing the direct OAuth endpoint on Facebook and using workplace.com. With the Facebook endpoint, it would prompt the user for a confirmation dialog, but on Workplace, it doesn't. So when it sees that empty key, usually it'll try to prompt for like a confirmation on the user side, but on Workplace, it doesn't do that. It just directly issues the access token.
Yeah,
So
so I'm not sure if you necessarily say that usually will prompt for that. It does seem like that's basically the fallback to, hey, there's no app ID provided here, therefore make them go through the whole authorization again to make sure, you're going through the right app. Um, but yeah, and then Workplace obviously just ignores that. Oh, it's blank. Well, I won't bother checking it then. Uh, that seems to be kind of the case along all three of these. Is Workplace just does something stupid.
yeah. The third bug was a direct bypass of the whitelisting in the Facebook and Workplace web view. Facebook whitelisted it so only FB and FB work would be allowed, since it would seem they thought those were safe. But Yusuf found a strange behavior where if they specified an arbiter or a dialog return arbiter endpoint, and also changed the URI scheme from a normal HTTPS link to the FB scheme, it would redirect to facebook.com under that same URI scheme with an access token. This one was a little bit weird. I don't think there's really too much detail on why this could be the case, because you kind of have to speculate. Um, but yeah, this one is probably the weirdest of the issues
Okay, I
that were
didn't
reported.
find it too weird. So, I mean, the fact that it goes and first, we've talked a little bit about the XD arbiter and this dialog return arbiter. That's where Facebook's kind of proxying. So we talked about this in the context of, was it like Facebook games or something like that, where you would have these applications hosted in iframes on Facebook, and then they would be able to communicate with through Facebook using the arbiter. So that's where there's probably some edge case about like, oh, if this is an arbiter request and the path matches like these things, go ahead and let it through. And then it ends up keeping that same schema, the FB schema, and returning to the FB // and then the proper path basically for Facebook.com. Because yeah, it will redirect to the FB scheme. So my guess is that just had to do with like some edge case on dealing with the arbiter. And there is probably somewhere that actually relies on that. It is a little bit of an ask in this case, I think, to be able to request or to be able to register that FB handler. Um, like an attacker getting access or being able to hold on to that one. I know a lot of phones come with like Facebook by default. Um, or maybe that number's gone down. I don't actually have the statistics on that.
That's interesting to
But
call out though, because I hadn't really thought about that. But yeah, that's totally valid point.
yeah, like so it's not exactly what or a whitelist bypass. It is using one of the like they do allow FB through normally. It's just you need an application. So all of these like all of the redirect URIs need to go through. Sorry, I had something come up and distract me over here. All of the applications need to have a redirect URI that is going to be whitelisted. So when you go through this, you provide your own redirect URI, and it's going to look that and whitelist those. So you not only need the right scheme in there, you also need the application that you're trying to authenticate as to approve or accept your URI. So that's where XD arbiter and the arbiter stuff can be whitelisted by some first party applications, whereas just any old random FB URL might not. So I think that also kind of plays into this a bit.
Makes sense when you break it down. So yeah, toward the end, the researcher got into some details on reporting the bug to Facebook, which didn't go too well, apparently. It went so badly for them, they said they quit the program for a while because of it. Um, Saying at first they accepted all the bugs as valid, first reporting the third bug, then the first bug, which he included in the same report, and then filed the second issue separately. Well, he only ended up getting paid for one bug in the report that had two bugs, which they admit they probably shouldn't have put them in the same report to try to save them time. But then they also didn't acknowledge the other report, saying it was known internally, in quotes, and it was a problem with the FP Connect success being used as a redirect URI, which the researcher claims the bug was actually the fact that some bugs would fail to get that valid hash key. After arguing for a while, it seemed that Facebook then fell back on saying the second bug reported was a duplicate of the first bug, even though they didn't pay out for the first bug, because they only paid out for the third one that was reported in that report. So, yeah, it seems like a really weird situation. Did get paid out for one of them with 10,000, but the other two were unpaid, which sucks. Um, It's also a little interesting because I believe this is the first time that I can remember that we've seen Facebook covered in a negative light when it comes to the response angle. The last few reports I remember is covering, it seemed like Facebook was pretty reasonable there, but yeah, at least in this instance, it seems, it didn't go so well on the communication between a researcher and Facebook. That said, we don't really know the specifics of what happened there. We only have this post to go off of. Um, and given the lack of what I've seen with Facebook with bad responses, like it doesn't look like they're not like Apple. Um, I would want to see more of a pattern of it before definitively saying like Facebook's bounty is bad or something. But yeah, the researcher in this report, they reported having a bad experience with that. Um,
Yeah, I mean, from past reports, I don't really recall any that were explicitly negative, but I don't recall any that were really positive either. Like, I just kind of have a neutral opinion at this point.
yeah, it could be that in this case, like there was a bit of confusion on like the triager side or something. It's totally possible, and that happens. So, but yeah, like I said, we don't really know what happens. But if you want to read a little bit more into that and what they're talking about there, that's like the bottom third or whatever of the post.
It is a little bit noteworthy that these did take nearly a year. They took 11 months to get fixed. The report was sent in October 2020 and then fixed in September 2021. Is a
Yeah,
bit of a is definitely a long patch delay.
and that kind of like fueled my suspicion that it maybe there was just some confusion on Facebook side, and they were maybe didn't understand the issues immediately or had to do some tracking down to fix them properly, and then that combined with the bit of arguing that was happening in the bounty discussion, that's my speculation.
Yeah,
But
it seems a little bit odd to me actually that we would have such a disconnect between the Facebook OAuth and workplace OAuth. Like I feel like they should be sharing code there. Um
generally, it's centralized. Yeah.
you would hope so. Obviously, it seems like they're not in this case, but that is something. Um
Oh, I mean, with other Facebook applications, it's centralized. So yeah, it's just weird that this like one app kind of stands out. Um,
a complicated other app, I suppose.
yeah, weird situation. But yeah, we'll move on. So PT Swarm put out a post with 3 vulnerabilities in Cisco HyperFlex HX, which is Cisco's hyper-converged infrastructure or HCI solution, which combines computing, networking, and storage into an all-in-one solution. This was by Nikita Abramov and Mikhail Kushnikov. Hope I said those right. Um, Basically, HyperFlex has a web admin panel for allowing you to, configure the system, create clusters, and all that kind of stuff. And the vulnerabilities have to do with that panel. So the first one we have here is a password input command injection due to how their auth flow works. Basically, the auth is handled by a backend Golang service that runs on the server, and it tries to hash the provided password and compare it against Etsy Shadow. But to do that hashing, it passes it to Python through a one-line Python script that gets called through exec.command, which is really weird and lazy. The issue there is obviously by putting a password that would escape the string being passed to the Python one-liner, you can get RCE right off the bat because you can just pass arbitrary Python to the interpreter on the server. So yeah, just one of those classic cases of being really lazy and it coming back to bite you in a really bad way. Um,
It's also just a really enjoyable case to see this where it's code execution in the password because I mean the login box is usually one of the most hid areas of an application when you're testing it. So
Usually the first
whenever
place you jump to, yeah.
yeah, it's the place everybody goes, hits it with a few things. Like everybody kind of tests that. Everybody's aware it's security, like that it has security implications. So like it usually receives extra attention. So the fact that like code execution in it is definitely just a standout issue. I mean, it's a stupid issue to even have here. I can sometimes understand if a library is missing, you need to kind of transfer over to another language. Okay, That said, I mean, a Python one-liner does feel like the wrong way to have done this. A separate Python script passing in as an argument, I think would have made more sense. They didn't do that in this case and kind of allowed this because, in fairness, using exec.command, they are passing in the arguments separately. So you're not getting like a more general like breakout into bash, but just being able to control like the argument dash C for Python dash C. That's enough for arbitrary Python code, which is enough for arbitrary code, of course.
Yeah, so just using an actual script file would have saved them from this issue.
Would have made it a lot harder to have this issue at least.
Yeah. The second bug was in the StoreFS ASUP endpoint, which would pass all requests to an Apache Tomcat server with the StoreFS ASUP class. When looking at that class, they found they were taking user parameters unsanitized and use them to build up a string that gets passed to the process builder to start a process. So again, just straight up command injection. Finally, the upload endpoint was unprotected from directory traversal. They did find some other issues with the default routing for any HTTP requests that don't meet the other rules. Those get passed to the installer Golang binary that's running internally, and kind of similar to the previously mentioned issues, the upload and update catalog API were vulnerable to path traversal, and that would be as root, so they would be even more powerful than the earlier mentioned directory traversal, where that was as Tomcat 8. But those weren't accepted as security issues because to use those endpoints, you needed an auth token. But PT Security still wanted to point that out, though, because it was still a poor implementation.
Yeah, so just to add on Cisco's behalf here, not only like the auth token, the way you would get that is by being able to log into the machine already. Because these credentials, like the reason why it had to go through the Python hash instead of including some hashing system itself. I'm not sure if you've got something quite like Crypt and Golang. I feel like you should be able to recreate the appropriate hashes at least, but maybe not quite as easily. I'm not sure. Is because they were reading the hashes out of Etsy Shadow and using that as their basis for authentication. So like the authentication level into this application to get that token is pretty high. Like it's not quite like your standard web app where these users are entirely removed from the users that exist on the system. That said, those users may not be root, and this does give root file read and write.
Yeah, so there could be a privilege escalation there, but I guess because of the high barrier to exploit it, Cisco just didn't want to classify them as security issues, which I don't think we would really agree with. But
I don't
mean,
entirely agree. Like, it's definitely a security issue. I could understand an argument like if you had to have the root credentials in order to do this, so like there's no escalation or no possibility of escalation, which is possibly the case. No, Cisco does know the system better than we do. Oh,
for sure.
in that case, like I can kind of understand it. That said, that also feels a little bit deployment specific because you might have access to, you know, the web interface because that's getting proxy through something else and not actually to SSH in. Like that might not be available, or even if a password-based login was disabled, then knowing the password to do the login versus or so it would match an Etsy shadow wouldn't necessarily mean you could SSH in. So like I feel like that is a little bit of a wrong argument to take. But at the same time, like I can understand it when you're looking at it from that perspective of these credentials already provide you so much access.
Yeah. Overall, though, some pretty significant vulnerabilities with the first three that I mentioned.
One thing I don't think you mentioned this yet. That kind of stood out to me was with the directory traversal. One of the things it was only accessible if you were if it was exposed over port 80 and not if it was exposed over 443 or over HTTPS. And so they just offhanded mention this Tomcat traversal of using like dot dot semicolon flash to basically mess with Nginx would match the route in one way, so it'd send it off to the one Tomcat process, but then Tomcat would process that another way, and it would give you access to a service on Tomcat that was running, but not directly exposed. I thought that was a neat trick that they just kind of had the offhand mention here. So I want to at least call that out.
Yeah, no, that was good to call out. I missed that. Um, yeah, some pretty significant issues. Also some pretty trivial issues. So it does kind of make you wonder, like, if these kinds of bugs are being found in it, then there's probably more to be found. Because these are kind of memeable, but
Yeah, definitely memeable issues here. Like, but that said, breaking rights for the guy that found this or whoever it was, being able to say you got RC on a password
that's pretty
is
cool.
yeah, I mean that's a bit of bragging rights, regardless of how stupid the actual issue was.
Yeah, for sure. All right, so Opera is back in the podcast with another blog post from them on a bounty they had submitted. This is another post from Renoir, who wrote up a bug that we covered before in the pinboards feature. That was on our September 14th episode. So last time there was a bug in pinboards. This time it's in the My Flow feature, which is used for shared and synchronized storage. It was an XSS through the drag and drop feature of the page for images. Basically, it seems they would just create a span element and set the inner HTML to whatever was passed in for the data transfer value when uploading, which can be arbitrary. And uh, yeah, you can just pass in like arbitrary HTML there.
Yeah,
And
so
it won't show like image tags properly in the HTML either, so it's kind of stealthy too.
it's supposed to. So when you do the drag and drop, like JavaScript can control for those of us for those watching, you can kind of see this e.data transfer. So JavaScript can control what that transfer actually looks like. By default, if you're dragging an image, it's going to be like that image tag if you try and grab the data text HTML for it. It's going to be like that image tag of the image. So they are relying on that sort of assumption here, forgetting that applications can cause other things to go in there. But yeah, and then coming into the actual attack, because JavaScript can just control that data transfer element, straightforward XSS, just replace with anything else. They use the example attack page of drag the cute cat to his home. Again, if you're watching, you can kind of see that click and drag happen. I appreciate that they went in to try and create the attack here, because you do need somebody to go and drag this to this My Files application. That kind of takes some intent on the victim side. Like, I want to put this image somewhere else, or I want to store it or do something, which is a little bit of an ask. They came up with a great sort of social engineered example where as soon as you start dragging, it'll redirect the page to the My Files, giving them that sort of attack service as long as the page redirects. Before you actually let go, it'll count as a drag and drop onto that application.
Not super stealthy though.
No, but I mean, there aren't a lot of ways you could be really stealthy with this sort of vulnerability. Like, it takes that user interaction, something's going on. That said, they did get code execution through this, which I haven't touched on yet, but kind of similar to the last offer when we talked about the extension exposed some higher privilege operations inside of it through the Opera Touch private object, which they can then access through this cross-site scripting, and that included send file and open file, providing read and write access to files.
Yeah, so this is even more impactful than last time, because if I remember correctly, last time it was just the open file. So like the whole attack there was opening a local file on the user's behalf and then exfiltrating that. But here you can do a write too, which is obviously pretty significant. So yeah. So earlier, I mean, on the stealth aspect, they pointed out like the image won't show properly in the HTML, and I was kind of thinking how that could be stealthy, but yeah, when we started talking about how you'd have to pull off the attack, I guess that kind of eliminates that angle, because as the image kind of shows, it's pretty obvious when it switches the tabs on you.
Okay,
But
I guess I might need to clarify here a little bit. They can open the file, they don't, or do they write one? Sorry, so I just got a little bit confused here as I saw the send file and open file. The send file though seems to upload it to MyFlow. Oh, there we go. Sorry, I couldn't find this slide, so I was starting to think I might have remembered it incorrectly in terms of the write, but no. Okay, so they do have a write.
Okay,
Ignore
yeah,
my
it also
rambling.
saves to the user's computer. Yeah. All right. So we'll move into our last post of the episode here, which is a post from Sirius, which talks about prototype pollution, which I don't think is something we've really talked about before. We might have talked about it once or twice, but it's definitely been a while if we have.
I don't think we've actually covered the issue at all in the podcast.
Yeah. So prototype pollution is basically where a prototype of a base object gets tainted or polluted in some way, so that like a poisoned property can end up being accessed later in a dangerous way.
Yeah, so
So
if you're not familiar with JavaScript, because this is somewhat unique with JavaScript, it's similar in concept. I could draw some similarities between it and sort of a mass assignment type of situation. Not quite, so maybe I won't go into that. But with how JavaScript objects work, is you've got this uh, dot prototype or underscore underscore proto underscore underscore. And if you set values on that, it'll set those values on all objects of the same type. So like if you do object.prototype and then set like some field on that, it'll set that for every object that inherits from object, which is every object. So it's a way of basically impacting other objects that the JavaScript uses if they just kind of rely on them being set or not being set, or like just checking them when they parse something, it'll get set. So this basically lets them inject certain fields or values into it. What I thought was interesting out of this post, and first of all, I am going to say there are a lot of things I don't like about this post. We actually consider just dropping it, but I think there's value in talking about how they actually went about trying to find these issues. And because that's just messing with like the JavaScript objects, you still need to have a gadget that is useful. This also includes kind of how they went about finding those script gadgets that they could use this. So I think the methodology, there's a lot of value when they're talking about how they went about finding these issues. But there's also it's not the most accessible if you're not fairly familiar with how prototype pollution works in general. It is kind of written with a bit of a barrier to entry.
the other thing is too is while they do go into the methodology, it's mostly like a higher level overview. So for example, like they highlight two cases specifically that they were interested in finding to check for prototype pollution type issues. The first case being they wanted to check for apps that would parse queries or hash parameters and check if it ends up polluting the prototype of the process, which they did by writing a Selenium bot and a browser extension. The other case they wanted to find was where any user input or data processing on the client side could lead to prototype pollution, saying that that would lead to like a self XSS most of the time, which is harder for an attacker to get control over the input. But they also noted that most of the time, like a self XSS can be converted into a reflected one. They don't go too deep into the process though. Like they mentioned that they use CodeQL. They in the post directly, they don't really go into details on the queries they use. They do link out to some of them in their like case study section. So you kind of have to go and follow those links yourself if you want to check out the queries, because the post just doesn't really touch on them too much. So I did just want to call that out as a you have to do a bit of extra work, I guess, if you want to. You kind of have to break down the queries yourself. The post doesn't do it for you. So yeah, I mean, they also talk about some of the recon work they do to determine like what library contains the vulnerability that they find with those automated tools. They talk about finding script gadgets to cause JS execution, which again consisted of like keyword search and code review. Toward the end, they go into the 5 case studies, which this is the section where I don't think it's really that great the way that it's written. Some of them, like mainly the fourth one they cover, it seems to me that details were skipped that makes it very hard for a reader who's not familiar with the target application to understand what's even really being talked about. And some of the like things they mention with like bypasses and stuff don't even really make sense, which maybe we'll cover in a few minutes.
And
Um,
we'll get to it for sure.
yeah, so it's possible that that's partly a lack of understanding on our part. Like I'm not super familiar with prototype pollution. I haven't really done it. Um, but I do know JavaScript, and you know, like I said, some of the bypasses and fixes they mentioned don't really match up with what I'm reading. Anyway, we'll get into some of those case studies. Um, the first one is a bit vague due to the nature of it being reported to a private bounty program, so there's not too much to talk about there. Um,
No, and I really wish they would have included a little bit more because they have one detail that is a little bit enticing to know more about. Effectively, all this one was though prototype pollution, of course. Um, why can't I find it on the page? But yeah, they don't include much information. But what they did gain, here we go. Uh, Basically they controlled this blob URL, so new worker blob URL. So they controlled the URL that a web worker would be getting its source from, which is a interesting primitive to have for really any sort of attack here. Um, it didn't give them access to the DOM, so like the actual code or anything on any of the pages though. Which, disappointing. But then they talk about how they escalated this to an account takeover, and effectively it's, they use that access to take over by opening sensitive pages in iframes and Windows and use SAML to log into our account and read the data and sensitive pages to take over the account. I would like to know more about what their attack was here. I can reason about what's going on here, opening up pages while logged into one account, logging into another account over the SAML interface. I kind of get that. I just would like to see it explained a little bit more. Obviously, private bounty, they can't. I don't blame them for not including that. But it's just an enticing little tidbit there that actually kind of makes this a little bit more interesting.
yeah, just personally, you kind of wanted to know more there. Yeah. Um, but yeah, I mean, don't have too many details on that attack, but it did net a $4,000 bounty. So, um, yeah. The second one was in Jira Service Management, where a backbone query parameter was vulnerable to prototype pollution. They were then able to use POSIX to find a gadget that worked against all Jira sites, which used an on-mouse move callback to get code execution. Initially, this was reported to Mozilla, thinking it was specific to them, but then later on they realized it was on all self-hosted Jira sites under 4.16.0. So they reported it there. It got fixed. The fix was insufficient initially. They just tried to do a blacklist against underscore underscore proto underscore underscore and the constructor and prototype keys. But then they later on stripped square brackets from the keys when setting parameter values. So by abusing that filtering to just pass in a keyword but throw in some square brackets in there that get stripped out, it would bypass that check and still pollute the prototype, which I thought was kind of a neat bypass, abusing the filters against themselves. So that got 2K from Mozilla, and Blackvan got awarded $600 from Jira as well. Um, the third case study is in Apple.com and in the Apple Watch spy page. This was when they parsed the location using the CanJS param library. They don't really talk about that, but they do link to the vulnerable code fragment in the library where it parses out key pairs. Again, Apple tried to fix this by blocking the proto keyword, but they didn't block constructor prototype, so it was an insufficient blacklist. Seems to be kind of a common issue in the initial fixes for these bugs. That netted a $6,000 total for reflected XSS. The fourth case study is where it gets a little bit weird. I'll try my best to cover it, but some of the things don't really make sense to point out here.
Yeah, it gets a little bit weird, but part of that is because this is an issue, HubSpot Analytics. So this is something a lot of different websites are including in their application. So the problem there then being that there is no like concrete, well, they didn't find like a concrete attack that just could be against everybody. It kind of depends on the applications and how they use any of the HubSpot data or how they use objects, I guess, not just HubSpot, um, after HubSpot has run. So they do kind of lack that more concrete one. Uh, but yeah, they just mentioned it was using dprim. One of the JS files parses the query. So you've got prototype pollution there. Most of this post ends up focusing on their bypass. The first one, they blacklisted only _ proto. Like we've seen already, a bad blacklist. Therefore, it could just be bypass, use the constructor, and then they can provide the proto to that, or prototype to that. One thing I'm unclear about is they fix the bypass by creating the statement in this report is they fix the bypass by creating a null object. That sounded to me like, well, they created like another object type, therefore you wouldn't be impacting the object. So like your prototype wouldn't impact just objects in general. That's kind of what it sounded like. Although then this next bypass doesn't really make sense. At least in my head, it seems like, well, then, even though they get pollution again, bypassing, their next bug fix or their next fix, they still shouldn't have been able, like, whatever the null object did should have worked here. Yeah, I'm confused by exactly how that fixed it. Maybe somebody else who's been more familiar on it, who's looked at this, might be more aware of why that fixed it. But yeah, that one line kind of threw me off, and I just kept going to try and understand this next thing, which is this Nikita Stupin found a bypass to their actual block list. So they had a more effective block list, and this is actually a really cool bypass, where they take advantage again of some of the code that existed in the application in order to put into a bit of a weird state that would skip the blacklisting. That said, they don't really explain it very well. You just kind of get this image that explains it if you understand what it's doing.
You basically have to reverse the code snippet that they post to figure out what the actual bypass is, because they don't detail it at all.
Yeah, so I'm at least going to make an attempt to explain it. You need to understand the code that's going on. So I do apologize for those of you just listening. I'll do my best, but I can't make any promises that you'll quite understand. So what they did, or what they have in their parsing, is they separate it into two things: simple keys and complex keys. Simple keys are just in your URL. If you have like A equals B, that's a simple key because A does nothing special. It's just a value, and you're just assigning it a value. So that's considered a simple key, and they don't do any parsing on those. And part of why that is still a bit of protection against prototype, because technically you could do like _ proto and, some single value, but the effectiveness of prototype pollution is when you're setting subfields on it. And that requires you set a complex key where you have both a key, square bracket, and some other key, some other subfield that you're setting, and the square bracket and the value for that subfield. So they have it split up into that. And one feature that they have is if you do something like A equals 5 and A equals 6, so you set that A value twice, it'll automatically convert that field, or the key A, into an array, taking the existing value that it has, and then the second value of the array will be whatever the new value was. Or they'll push on to that in the other situation. So they take advantage of that case to basically set the key on _ proto _ or just your prototype as the key. It doesn't need to go through the blacklist. The blacklist is only for complex keys. So they set that, and it's going to think it's an array. because the way it checks that is just like if this object and that key, if that's undefined or if it's not undefined, it'll turn it into an array. So it sees this key proto, looks at it and says, okay, let's turn this into an array because it already has a value. So what's that value going to be? Well, the value that's already there at object proto, which is the prototype value for objects, and then whatever value you add onto that doesn't really matter. They just left it blank. So then when their second half of this bypass comes in, it's 0 as the key, and then inside the square brackets just taint whatever you want to pollute. So because they set up the object's prototype to be this array, that means when they now try later, when the second one comes around, it's going to access the first element of that array, the 0th key. It's going to access that key, which is the object prototype, and set taint or whatever prototype you want to taint on it that way. So that's how it gets through the bypass, or it gets through the blacklist, because 0 isn't a protected key, of course, but because of that first step, 0 will become the prototype, or the 0th key will be the prototype. So I think it's a really cool bypass.
It's kind of like this multi-stage pollution.
Yeah, like you have to set yourself up in order to take advantage of it. Like I said, multi-step, multi-stage. And it takes advantage of like the existing code and something that seems pretty innocuous. Just we're creating an array. I mean, it's a cool bypass. I wish they would have at least tried to explain, because I just had to like mentally look through all the code and kind of figure it out. It wasn't that bad to figure it out, but it would have been nice that they laid it out a little bit better than just an image on screen saying like step 1, 2, and 3.
The way it's written is like kind of saying like you should be able to read this image and it should be obvious, right? But I don't think that's really the case. I don't know if that's just because they were like so familiar with it, they thought it would be obvious to anyone, so didn't really warrant explanation. But
that's what I feel like,
really
because
one there too.
Like now that I understand it, I look, that's like, yeah, I get exactly what they're saying with the image. Image makes perfect sense to me. Now that I've gone through that first step and like understood it, looking back, like, yeah, okay, I get why they made those choices. So I think you're right with that it's just one of those things where, looking back, it's really obvious to you.
Yeah, exactly. There was a 5th case study that was put there as well, in segment analytics, which uses query string. This one was unique from the others in the way that it required the property to be numeric. So they had to find a gadget that allowed just numeric key pollution, which they stated, or a numeric property solution, which was pretty difficult. The one gadget they were able to find was in knockout.js, where it would construct a regular expression that gets ran against content displayed on the page, and that could be used to get XSS. But they didn't find, like, they weren't able to find any of the applications they were looking at to be exploitable to this issue. It kind of required a specific setup to actually use it, but that one was kind of interesting just in the way that you could only pollute like the using numeric properties. That was interesting. But yeah, I mean, overall, like you said, I think the methodology is probably where you get value out of the post. It is a bit high level, but they do link to the queries as well. Case studies could have used some better explanation though. But yeah,
I mean, on a whole, there were some places where it feels like they didn't include enough background information, which feels a little bit weird to me, because I'm often saying like I don't think they needed to include a lot here, and then they include more than we need. So, I do like it when we have things that are really concise. At the same time, yeah, I mean, I had to struggle through this one a bit, and it's not like prototype pollution's completely unfamiliar to me. But yeah, I think most of the value, though, and why I really want to include this is just the methodology talk. It is something that, like, we often just talk about. Here's this vuln, here's this attack, here's this other thing. And, you still need to go out and hunt for it and remember to test for it and find it. So it's valuable to share that methodology, too, even though sometimes it does feel like it's just really straightforward and like, of course, you just do this. not everybody's going to find it as obvious how you test for something. So, that was the big reason why I wanted to include this more so than the actual vulnerabilities.
On a broader point, something I was thinking earlier, and something from chat kind of prompted me to want to talk about this. Um, Korgal in chat said, "I'm only familiar with prototypes being bad usability and stability. Unsurprising, they cause vulnerabilities too." Um, yeah, I will say, like, I don't actually know why JavaScript lets you do this with like setting prototype properties and stuff like that. I haven't written a ton of JavaScript, but the bit that I have, I can safely say I have never used like object prototypes outside of like exploiting, like writing exploits. So it just seems like a really powerful and dangerous capability to expose for not a lot of benefit. I don't know if
So,
you have like a charitable angle to that, Z, but it
yeah,
just
I
seems
mean,
like something
there's
that's ripe to be abused and for no reason.
well, so with a lot of languages, dynamic languages, the dynamic nature creates these situations where you can do some really weird exploits. The same's true with most scripting languages. There are always some gotchas like that. That said, as for why these prototypes exist, you don't really have any other way to create like a generic object. You don't really have the same ideas of inheritance that you do in other object-oriented languages. So instead, you can kind of define the prototype to be like your generic object. You can create a sort of inheritance that way. So that I believe is why we have the prototypes in general within JavaScript. Is to have something reflecting a sort of inheritance system. I mean, not really inheritance, but that
Like a
sort of
hack of
functionality.
inheritance. Yeah. Okay. Yeah, I mean, it kind of makes sense. Like, and like, thanks for pointing that out because I'm not like most of my JavaScript experience has honestly been writing like WebKit exploits, which I kind of use JavaScript as a means to an end.
Have you needed
I
to
don't
use
really
any prototypes in a WebKit exploit? Unless, well, I guess, have you had any exploits actually in like the prototype code or something?
come to think of it, I think I remember looking at one that involved like an array prototype or something, but I don't remember the specifics of that.
Okay.
Um, but yeah, generally in exploits, even in exploits, I don't even really use prototype that much.
Well, that's
Um,
kind of what I was saying. Like, I didn't see an obvious place for it unless the vulnerability was specifically in like the JIT and how it or well, not necessarily the JIT, but in the engine and how it handled prototypes.
yeah. So yeah, it's a little bit weird because I use JavaScript quite a bit for like exploits and stuff, but I don't use it in the context of what it's usually used for, which is like the front end development, working with JS frameworks. I imagine there it's probably used like in frameworks, especially. I would suspect that prototypes are used. Um, but as somebody who doesn't work in that world, it just seems like such a weird like thing to expose that
JavaScript
opens
is a
up
weird
like a
language.
massive attack surface.
Like it really is just a weird language in general. It's very dynamic. It does some things that are really weird. Like the its whole object system is pretty weird compared to other languages. In fairness, it's grown over a ton of years and like it's had a long history with things. So like I'm not hating on JavaScript for it, but it makes some weird choices. Part of that because there wasn't really a standard at the time that it made some of these choices. So it kind of chose its own path, and these are the end results of it.
Yeah, and part of like um, along that line is why there's so many like browser bugs at the binary level is because under the engine, handling all that nonsense with objects and how immutable or how mutable they are and whatnot, like it is really damn hard at an engine level to keep track of everything. And that's part of why I find uh, browsers under the hood to be really interesting. When you look at how they keep track of like JS objects and JS values and all these like complex hierarchies and data structures they have to track it all, it's really interesting. But it also seems like stupidly unnecessarily dangerous. So yeah. But yeah, I don't really have anything else to bring up around this topic. Um, unless you do, Z, I think we'll go ahead and wrap it up.
Yeah, no, I think we can end it there.
All right. So thank you to everyone who tuned in. You can catch the VOD on Twitch. It'll also be up on YouTube and other platforms at 6 p.m. Eastern tomorrow. Feel free to join our Discord and follow us on Twitter. Links for those are down below, and I'll also put the Discord in chat as always. Discord is also where the solution, or where the Spot the Volume challenge will be posted, and we'll post the solution there as well tomorrow, after the binary episode. And yeah, as a reminder, we will be back tomorrow for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you all then.